Hello, this is K6OZY, and this is a two-part series video on how to set up SoftEther as a VPN server for general use and also for Flex users who want to use remote WAN before the official release. And then the second video will be on how to configure another Raspberry Pi with SoftEther to be used as a bridge until the VPN client is released in the native Maestro software. So this video is going to concentrate on setting up the server, which is what you need inside your home for remote VPN abilities. And this video is going to take some assumptions that you have gotten a Raspberry Pi. I'm going to be demoing this on a Raspberry Pi 3 because it comes with the integrated Wi-Fi, not necessarily useful for the server side, but for the bridging side later, it'll be very useful. So I'm using the same Pi for both, and I erased a test SD card and dropped a fresh copy of Raspbian Jessie. There's lots of documentation on the internet on how to do that. You can do it using Noobs or the Raspbian Jessie image directly. I'm using the Jessie image directly because I want to skip all that other stuff that the Noobs installer does, like expanding the operating system, and just use the OS that I know I need, which is Raspbian Jessie, and this demo is based on the version seen on the screen here, released March of 2016. So in this video, I'm going to show you how to set up the Raspberry Pi and statically define the IP address on your home network. I'll then show you how to install SoftEther as a VPN server. I will show you how to configure the VPN server using the SoftEther Server Manager software and the ports that I punched through my firewall to get it working. My firewall is a pfSense firewall. It will differ from yours, probably, but all you need to do is figure out the equivalent settings on your router to forward the ports that I'll be showing. So, because I'm going to be doing this without showing you the Raspberry Pi boot interface, I will show you a way to figure all this out even though you've booted your Pi and it's connected to the home network through an Ethernet cable. If you had a monitor attached to it, you would see it boot up with a GUI, but we don't care about that. Everything we're going to do through console, through the text interface, through SSH. Everything I do at work is all Unix based, and we don't use GUIs, so we're not going to use a GUI here. So you need to find out the IP address that your Raspberry Pi comes up with. If you have an Ethernet cable plugged into it when you boot it up, it will acquire an IP address on your network. If you have the monitor on it, you can click on the little network icon in the upper right corner and look at it that way, but the way I do it is I just look at my router's DHCP lease table, and you'll see that recently when I booted it up here, this Raspberry Pi came to the top of the list here, and it has an IP of 172.17.0.146. This will be different for your network, obviously, but this is the IP space for my home network. So this is the IP of the newly booted Pi with a fresh image on it. So now we need to SSH to it and do some configuration. I made a little bit of a cheat sheet for myself so I wouldn't get sidetracked here. So let's get started. The first thing we want to do is SSH into the Pi and configure it with a static IP. So on Windows, I usually use a Mac for most of my work at work because it's a Unix operating system. But on the Windows world, you need to get yourself an SSH client, and I recommend Putty. It's free, it's small, it's easy. Go here and download Putty. Save it somewhere on your machine here and run it. So I have a shortcut on the desktop here I made for the demo, and it's going to open up here. Now for the demo, I'm going to make the font a little bit bigger so it's easier for you guys to see it. And then I'm going to type in the IP address of the Pi that came up on the network here. So it's 172.17.01.46. I'm going to SSH into it. I'm going to hit OK. Now I'm doing this live. I don't really have the time to do a lot of cuts. So if I make a mistake, I'll just have to make a mistake while I'm recording it and back out of it and make the change. But I'm not going to make it all pretty if I goof up. We'll goof up together here. So just say yes to this, and let me resize this so it's a little easier to see. The default user for the Pi is Pi, and the default password is Raspberry. I suggest you change that. You can do that by typing passwd, and then you can change it, but for this demo, I'm not going to do that. Okay, I paused it for a second, but it's back and running now. Logged in as Pi. You can change the password if you want to. I would recommend it, but I'm not going to do it for this demo. So the first thing we need to do is we need to potentially expand the file system. The Pi image does not consume the entire SD card when you first install it. I only use these little 8 giggers, but we're going to run sudo raspi-config and expand the file system there. And it expands the primary root partition to use up the remaining part of the disk. It's pretty useful. And after it is finished resizing, you can reboot. You don't have to do that now. The next thing we're going to do is make the Pi not boot up into the graphical user interface. To do that, we are going to change the boot options, and we're going to pick console. When you install it, it's set to desktop. It'll boot the GUI with automatic Pi login. This time we're going to change it to B1, which is text console requiring a login. Okay, now at this point we're going to hit tab over to finish, and it's going to want to reboot. So let's go ahead and reboot. It's going to close that out, and this should stop pinging as it reboots. Wait for it to come back up. It boots pretty darn fast. Okay, it's back up. So we will SSH back into it. Set that to 14 again. Pi Raspberry. Okay, so now have the Pi set to boot up in text mode over every time. It saves memory because you don't have to waste all that memory loading the GUI. Okay, so the next thing we're going to do is we're going to reconfigure this thing to have a static IP. Now I actually still have my Raspberry Pi server up, but this is a new one, a separate one for the demo. And I'm going to assign it 172.1.17.09. As you can see, it does not ping. So we're going to reconfigure the machine to have that static IP. So to make it easier, I'm just going to sudo to root. This means I don't have, normally sudo command means that you type sudo space the command you want to use as execute as the super user. It executes it and then returns to the user you're in. That can kind of be a pain in the butt. So I'm going to type sudo su dash, and that puts me as root, so I don't have to do that every command. So in Debian, which is what this is a spin of, the under the etc network directory is an interfaces file. The interfaces file is where we are going to define this. So my favorite editor is VI. You can use Pico. Matter of fact, I'll use Pico because VI is a little too hardcore for new Unix users to use. So let's use Pico. You type Pico space interfaces, opens it up, and we're going to go down to where it says iFace interface ETH0. ETH0 is the nomenclature for the first Ethernet interface in the machine. We're I'm going to put a little hash symbol in front of it. It's going to rim it out, and we're going to type in our own inet static. You type address 172.17.0.9. This is where you substitute the IP address of your home network you want to assign this at. Usually home networks, most routers are like 192.168 something.1. You can assign this to .2, but my demo here I'm .9. So netmask 255.255.250, typically always a /24. And the network is 172.17.0.0. Now that's usually a 192.168 whatever .0 for the router that you're probably going to do. Broadcast is 172.17.0.255. Again, for your network, it's probably 192.168 something.255. And I use a weird gateway just to make it not normal. So my gateways is this, but most people are 192.168 something.1. Then I'm going to exit and save, Control X in Pico, yes, and then enter to keep the same file name. To make sure it saved it, you can type cat interfaces, and you can see that it did stick. The next thing is we're going to edit what's called the resolve comp file. The resolve comp file is the file that is used for the system to generate for DNS lookups and suffix searches. So change this to usually your router's IP of 192.168 whatever .1, and then save. Whoop, Control X. Come on. Sorry about all the beepings. Why is it doing that? I don't know why it's doing that. Let me just kill it. Come on. It's funny. I edited it in VI. I'm so used to editing it in VI, but then I was sending it Pico commands. My bad. Sorry about that. So cat resolve comp. Now here's like the little catch-22. You could do this from the Pi directly, because when I restart this interface, while I SSH into it, it's going to cut my own throat. It's going to disconnect me here. So if you were running this on the Pi itself, it would be more graceful. So you could do that, but I'm going to do it this way. So I'm just going to reboot it. And it's going to come back up as .9. Change this to .9, start pinging. And while that's booting back up, I'll get rid of this interface 1 second. Okay, there we go. Now it's pinging. Now, I had to cut for a second because I made one mistake in that file. And let me go show it to you when I boot it back up. It was almost right. I forgot this, like if you look over here, I forgot to put auto each ETH0. So I forgot to do that. That means to reconfigure this on boot. And that was my bad. Doing this from memory. So back over here, we're going to SSH into its new IP now. .9, it's going to complain that the key's changed. Well, it's a new key for a different IP. That's fine. Pi, Raspberry, and we're in like Flynn. Okay, so I'll go cat that file so you guys can see the typo I made. So I forgot to put auto ETH0 right there. So make sure you do that. Otherwise, it'll ignore everything you type in there on boot. So anyway, okay. So next thing we're going to do is we're going to download the newest version of SoftEther. Now, what I do is I go to it on the web page here so that we can see the URL, and then I paste it into the terminal. So I'm going to go to SoftEther download, component, server, platform, Linux, CPU type, ARM EABI. That's what the Pi is compatible with. Now, if you click this, it would download it to your Windows machine, which you don't want to do. But if you right-click it and pick copy address, it'll copy it into the clipboard, and then we're going to paste it over here. So in Raspbian, there's a multitude of ways you can fetch a URL, but I use wget. You type wget, and then you right-click to paste it in there, and you hit enter. And now it's downloading it to the home directory of the Pi, user Pi, on the Raspberry Pi. Now, if you do an LSLA, you'll see there's the binary. It's 5.6 megs, pretty small. And now we're going to extract it. Now, I don't expect you guys to memorize all this. I've been doing this forever, so it's second nature, but you're going to extract the tarball, which is what a zip file is in Unix. So we're going to type tar zxpvf, I'm not going to go into what those switches do, and then SoftEther, and hit tab. Once you type SO tab, and it will complete it. Hit enter, it extracts it. Now we need to compile it. So we're going to cd into the VPN server directory, and we're going to compile it. So ./.install. Now I know you probably don't, ./. Okay. The first period means this directory, / and then the file name is actually, as you can see, there's period install.sh. Do you agree with this installation? Yes. Whoops. Did not mean to do that. Just want to make sure it's still recording. It is. Hit 1. Yes, accept. Yes, I accept. Yes, I agree. I'll sit here and compile it. While it's compiling, let me open my cheat sheet so I don't make a mistake here. Okay, so it's compiled. I normally never leave the binary directory in the home directory, so we're going to move it. Again, we're going to type sudo su dash become root. User, normally a lot of people will install stuff into OPT, but I'm going to put it in the directory user local. So I'm going to type move home pi VPN server dot, and that moves the directory out of the Pi's home directory into this directory, as you can see it there. Now it's owned by user Pi. I'm going to change ownership so it properly matches the rest of the stuff here. So we're going to chmod it, chown it. Sorry, not chmod. Root staff r VPN server. I mean, chown means change ownership, username, group, recursive, and then the directory. So now you'd see it's owned properly. Okay, now you could start it by hand, but it won't start up every time your Pi boots, so we want to make it start up. So we're going to create an init script. So you're going to cd into the init.d directory. This is where all the startup scripts are to start everything that the system does, and we're going to create a new one called vi. Well, I'm not going to use vi, pico space VPN server. And I put it in my little notes here so I can just quickly paste it. The script that I put together a long time ago for this. Paste that all in there like that. And then Control X, yes. Enter to save it to that. Now you'll see that there's a script here called VPN server at the end. Now you need to make it executable because right now it's not. So you're going to chmod plus X, the executable bit for VPN server. Okay. And then see if it runs. We just type VPN server, hit enter, and you can see the usage start, stop, restart. Okay, so it still doesn't automatically start there. We've just created the script to do the start and the stopping. So now you need to update the startup scripts to launch it on startup. And there's a little program called rc.d. If you hit enter on that, you can see this is what you can use to manipulate services in the system. So update-rc.d, we're going to type VPN server space enable. And one second. My bad. We got to enable which run levels. Run level 3 is what we're in now. 5 is for GUI. So we're going to do enable 3.5. Wait a second. I'm doing something wrong here. Okay, so yeah, my bad. You just type update rc.d VPN server space defaults. I just already ran it, so it's going to just complain about that. But that is what you do. Then we're going to start it up. Service VPN server start. And now we're going to see if it's in memory. So PSAX will show us process list, and you can see that the VPN server is running in memory. Now, just to make sure that it starts on reboot, I'm going to go ahead and reboot the machine. It's going to reboot real quick. You'll see it stop pinging. I'm going to close that while it's rebooting. Change this. I know I would, this time I'm going to save this as a profile. I didn't want to save it before because I was going to change the IP, but after you have your PI created and you get PuTTY set up the way you like it, then you can go in here and just name it whatever you want. I'm going to call it Pi Demo and hit save. That way I don't have to do that every time. Pi, Raspberry, and now we're going to check to make sure the VPN server is running, PSAX. There it is. Okay, so, all right, so we've gotten the server part finished. Now the rest of the configuration we have to do for the server is through the GUI, the server configuration GUI, and then your router. So for now, I'm just going to minimize that out. And now you come back to this page and you go freeware, server manager for Windows, platform, and then download this and install it. I know it looks like it's the full thing, which it is, but when you do the install, just install the manager and not the server, and it'll drop this on your desktop here. So we're going to run this, and we're going to type new setting. You can call this whatever you want, like your home VPN server. I'm going to call it Pi Demo. Host IP is 172.70.9, and hit OK, and then hit connect. Now the first time you connect, it's going to ask you for a new password for this demo. I'm just going to keep it Raspberry. Obviously don't do that. Password's been changed, and it starts up. Now it's going to start a wizard, and the wizard's quite nice. So we're going to set up a remote access VPN server, hit next. Yes. Virtual hub name VPN, just leave that alone. Now this is the dynamic DNS part. I would highly recommend putting something unique in here. I normally use the call sign of the person that I'm setting this up for, but you can set this up to anything you want, but just remember it. And this is what you're going to use on the other side to get home back to your machine because your IP changes. So we're just going to go ahead and set it to that and hit exit. You're going to want to enable L2TP right here. The reason is because this server can also be used with Stu's wonderful K6T remote app. And if you enable this, then you can VPN into your home using your iPad or your Android or iPhone. So enable that pre-shared VPN key. You can change this if you want. Just remember that when you set up the connection on your Windows or mobile device, that if you're using IPsec pre-shared key, you got to type this in. I'm going to leave this alone. Leave it as VPN. This Azure crap, say no. And then we're going to create some users. So the first thing we need to do is create a user. I'm going to create my call sign. I normally create the call sign of the person involved. Chris. And password here, I'm going to put Raspberry. Again, I do not recommend that because this is going to be something people could bang on from the internet. So make this fairly strong and hit OK. And you can make as many users as you want right there. And then you click exit. Now, the bridging is an important thing. ETH0 is the Ethernet interface. This tells the VPN server that you're going to bridge everything that's on ETH0, your home Ethernet, onto the VPN. So make sure you pick ETH0 right here and hit close. And that's it. And now it's running. Now, you'll notice that it's listing on a bunch of ports here. Now, the reason this is important is that most home ISPs block common ports like port 80 for HTTP and port 443 for HTTPS. So it's important that we use one of these other IP port numbers for the management connection, the TCP listener. And I've just chosen to use 5555, and I'll show you in the router configuration in a second. But just remember, you can use any of these. I'm using 5555 on my port forwarding. And okay, so now we're going to move over to the to your router. Log into your router's IP web page configuration. It's usually type in the IP address of your gateway. Mine is .11, so we're going to go over there like you saw earlier. But then on the firewall here, I go to NAT. It's different for everything you do, and I moved my rules to the top. So we care about these top 3 rules that I create for SoftEther. So you need 3 ports. You need port 500 UDP, port 4500 UDP, and port 5555 TCP for the management connection. So I'll edit these so you can see what they look like. I know it's different for every piece of software. I'm going to listen on my WAN interface, and I'm going to forward to .9. My real Raspberry Pi that I use every day is .10, but in this case, you put in the IP address of the static IP we just configured, pick the port. These are common ports, so this software actually has the proper service names for each one of these. So I'm doing that for port 500, and then I'm doing it again for port 4500, which is IPsec NAT, and then TCP 5555, TCP 5555 to .9 5555, and hit save. And that's it. You've now configured your home VPN server, and it will work fine. So at this point, what I would recommend doing is taking your iPhone or your Android or whatever device, or even another Windows machine that and doing it to test. I can show you how to set it up here in Windows 10. Let's imagine this was a Windows 10 laptop that you had off-site and you wanted to configure it. So let's do that. So I'm going to click on the little bubble here, click on VPN. It's going to open up the VPN interface, and it's going to be empty because this is my home computer. I have no need to have a VPN on here, but we're going to set it up. We'll go ahead and VPN over to that machine. I'm going to add VPN. We're going to use the Windows built-in. We're going to call it Pi Demo. Obviously, you can call it whatever you want. Now, this is where you typed in the address of that softether.net, that whatever you chose, callsign.softether.net, right here. But because we're inside the same network, I'm just going to type in the IP of the Pi. Now, it'll try to automatically detect what you're doing, but just to make it simple, pick L2TP IPsec with pre-shared key. And there's the pre-shared key I told you about a second ago, where you can change it to whatever, but I had it as VPN. Username and password, I had K6Aussie, and I had Raspberry. as my password and hit save. Now, if you're running the newest version of Windows 10, one thing you might want to do is edit the configuration so that all of your traffic is not sent through your VPN connection. This will allow you to use SmartSDR to talk to your radio, but not send all your internet traffic through your home. So let's say you're at a hotel and you want to use your radio remotely with your laptop. You want your radio traffic to go over the VPN to your home, but you don't want your Google and Facebook and all your mail stuff while you're at the hotel to go through your home before it goes out onto the internet. By default, it will, unless you undo what I'm about to show you. So we're going to go to change adapter settings, and you're going to find the disconnected L2TP port that we just created, and you're going to go to properties. Then you're going to go to networking. You're going to highlight TCP/IP version 4, go to properties, then click advanced, and then you're going to uncheck use default gateway on remote network. This means don't send traffic that isn't for the immediate things on that network to the remote network. That way your radio traffic goes to your network only, and all your other traffic while you're in the hotel goes directly onto the internet. Hit OK, hit OK, hit OK, and then you can close that. You won't have to change that again. Then I'm going to click on here and hit connect. And let's see, it immediately rejected me there. Let's see why. Did I type the username wrong? 1 second. Okay, I'm back. I typed the password wrong. So make sure you type that password right. I went in there and corrected the password. I must have fat fingered the word raspberry. So then highlight it, click connect. Connected. Bam, that quick. Connected. So if you wanted to verify that someone's connected on the Pi side, you can go back to the manager here. And if you manage the virtual hub here, in the bottom corner, manage sessions, you can then see connected sessions. And you can see I'm connected here. If I disconnect, hit refresh, I'm gone. Connect, hit refresh, I'm back. Okay. And that's it. You'd be doing this on your laptop outside of your home network, and then launch SmartSDR and connect to your radio. All right, and then you just leave that running. I never turn it off. Okay, well that concludes part 1. Now you have yourself a SoftEther VPN server running at your house for remote access. You can do it more than just for your radio. You can use it to access anything in your home network. But this is concentrating on showing you how to use SoftEther VPN as a home server so that we can get your Maestro to connect to your home radio remotely until the VPN client is a native, coming soon after the initial release. Okay, I'm going to nuke this Pi image and redo it as a fresh image of Raspbian, and I'll be back with part 2, and we will build the SoftEther mobile VPN bridge. All right, I'll talk to you guys later, and thanks for tuning in. And 73.